Hello, welcome to the last week of the ECE9013 course. In this week's lecture, we will be discussing some of the most well-known searching and sorting algorithms. So searching algorithms are basically methods to find an item or a group of items with specific properties within a collection of items. The collection could be implicit. For example, finding a square root can be done as a search problem. You can do it through exhaustive enumeration, for example, using bisection search, using Newton-Raphson. Another way to think about it is if the collection is explicit. For example, is a student record in a stored collection of data? So here we present two different searching algorithms. The first is the linear search method, which is a brute force search. That is, it's simple. It looks at each element and determines whether it finds the desired element or not. In this case, the list does not have to be sorted. Another searching method that is also well known is the bisection search method, or what we call the binary search method. In this case, the list must be sorted in order to give the correct answer because we make use of this property. In the previous week's lecture, we provided two different implementations of this algorithm. So as a recap, with the linear search method, which can be implemented on an unsorted list, we must look through all the elements to decide if it's there or not. That's why we iterate over the index of the list and check whether the element that we're searching for is found at different indices. In this case, the overall complexity is O of n, where n is the length of the list, because we have to go through the complete list. Now, assuming that the list is sorted, we can implement something similar. However, the only difference would be is that if we ever reach a value that is greater than the element that we're looking for, we can directly return false. And this is making use of the sorted property of the list. However, again, the overall complexity is O of n, because we would still need, in the worst case, to go through the complete list. Now moving to the bisection search method, as mentioned in the previous week's lectures, the way that it works is that we pick the index that divides the list in half. We check if the element within that list is equal to the element that we're looking for. If not, we check whether the element at that index is larger or smaller to the searched element. And depending on the answer, we either check the left-hand side or the right-hand side of the list. So this reduces the search space and hence reduces the overall complexity. So this provides a recap of how we can do that. So we've shown that this implementation of the bisection search algorithm has a complexity of log n because we would reduce the size of the list by half in each iteration. So as mentioned earlier, if we use the linear search method, we have the complexity of O of n. If we're using the binary search method or the bisection search method, we can find the element in order of log n. However, the assumption is to be able to use the binary search is that the list is sorted. Now the question becomes, when does it make sense to sort first, then search? Because sorting, then searching might be larger, or usually it is. So, to sort a collection of elements, we must look at each one of at least once, which means that in general, if we're only doing the search once, it doesn't make sense to do the sorting. However, we can actually amortize the sorting cost. In some cases, we may sort the list once, then do many searches. So in this case, we amortize, or basically divide the cost across multiple searches. So in this case, for a large enough K, the sort time becomes irrelevant. And hence, it would make sense to sort once and do multiple searches. Thank you.